We are now introducing a few symbols that you might see in a circuit diagram. First, we may talk about this before. It's called independent voltage source. So this circle with a positive and negative sign within the circle, it is called independent voltage source. It generates a predetermined voltage. Okay, and for this plot, it is an independent current source, and it generates a predetermined current. Okay, so the direction of the arrow means the direction of current. And so if it's written like this, DC equals 5 ampere, it means it's a DC current. If it is written as I of t equals 10 sine 100 pi t ampere, it means it's a AC current. And this is the amplitude. And this is frequency. Or more correctly, it is angular frequency. So 100 pi, it is we say it is omega. And so we usually for this AC current, we say we will write this. Wait, IT equals to A. A means amplitude, sine omega t. Okay, so this is angular frequency. Okay, and the unit of angular frequency is radian per second. Radian per second. And so omega equals 2 pi f. So this is frequency. And the unit is hertz. Okay? So in this case, the angular frequency is 100 pi. 100 pi equals 2 pi f. F equals 50 hertz. Okay, so what inside? So hertz is 1/second. Okay, so what inside the sine and cosine? The frequency inside this sinusoidal function is angular frequency. If you want to convert it to frequency, you need to apply this formula. Okay, and then you got hertz. Okay, so that's the difference. You have to pay attention. Okay, but so this is for current source, the the AC the AC and DC, they share the same symbol, but we just write the description to describe. So if it just say 5 ampere, then it's DC current. If it says a function of I, it means it is AC current. Okay. Okay, now we go back to a voltage source. So so similarly, this is we call this is DC voltage source, and this is a load. It's a block, so we don't specify what kind of electric element it is. And for AC voltage, so for AC voltage, you can see there's a sine function inside the circle, and we still give it a positive and negative sign, although for AC voltage and AC current, uh, this this sign changes direction periodically. And same thing, we write a function, we write voltage as a function of time, and it has amplitude and its angular frequency. Okay, so so for so the plot here, the plot here, it draws the time function of the voltage. And for example, for this, its angular frequency is 100 pi. So by the same thing, f equals omega divided by 2 pi. So it's 100 pi divided by 2 pi is 50. It means its frequency is 50 hertz. So its period, this is the t means period. T equals 1 over f, which means 1 over 50 second. So t is period. Okay, so which means the time for a complete wave, and its period is 1 over 50 second. So for DC and AC voltage source, their symbol is different and their description is different. Okay, so the DC voltage source, it has a positive and negative sign within the circle, and it just say 5 volts. But for AC voltage source, it's a sine function within the circle, and it is written uh, a time function. The voltage is written as a time function, and it will specify amplitude and angular frequency. Okay. And so it is independent of the current flowing through a voltage across any given element of circuit. It's independent. It will be always these values. Okay. One more thing to show on the bottom on the bottom right corner. So for let's look at this first. For voltage source, and although it only specify the voltage value, and there will be a current, and current flows out from the positive terminal of a voltage source because it's always giving energy. So you will have a current. Okay, and please look at this bottom right. For a current source, even though so here it is an AC current, right? Because the current is written as a time function, and but even though we do not specify, it still has a voltage, and because it's AC current, the source is AC current, and its voltage across this current source is AC voltage. So it is written as V of t. All right. But this V of t is not given. It depends on the circuit this current source connects to. So this Is of t, it is given. It will be always its amplitude and frequency will always the same. But Vt, the amplitude of Vt depends on what kind of circuit this current source connects. But they share the same frequency. We will talk more about AC analysis in the following chapter. Not right now, but right now you just need to know, even for a current source, uh, it still has voltage across this current source. So we also have voltage across this DC current source, and we still have voltage across the AC current source. But the value of voltage depends on the circuit it connects. Okay, this is what you should know about. Okay. Um, so we have independent voltage source and independent current source. Then we also have dependent sources. So we talk about dependent voltage source first. So it is a shape as a diamond, and it has positive and negative sign on it. So there are two types. First type is called voltage control voltage source. For example, um, let me draw a um, very simple diagram. Um, maybe okay. Maybe so. This is it. So it means it means the voltage here. Um, let me Um, so it means the voltage is depends on is 4 times of VB. So it may be V. The voltage V of this source depends on the value of some other element in this circuit. For example, let's see, we have positive. This is maybe Vs, and okay, this is RB. So this is positive, negative. This is VB. And we have a dependent, this is RA. We have a dependent voltage source and its value. So we say this is VA equals 4 times VB. So the voltage, this dependent voltage source, its voltage output equals, it depends on a certain value. In this case, it depends on the voltage across RB. So it's called voltage control voltage source. Okay. And if here, if we can calculate on the right circuit, on the left circuit, we can calculate IB. Okay, so if you are written VA equals 2 times IB, then we call this dependent voltage source is current control voltage source because it is controlled by a a current value of flowing through a certain elements in the circuit. Okay, so that's the difference. So dependent voltage source, its voltage value depends on either the voltage or the current of a certain element in the circuit. Okay. But for this example, there are two independent circuits. Okay. Okay. And we also have dependent current source. So in this case, dependent current source is also a shape of a diamond, and we have an arrow within the diamond, and we can specify. So here, now you know it is a voltage controlled current source. This current source is controlled by certain by the voltage across a certain element in the circuit, or its current value equals 6Ix, and Ix is the current flowing through a certain element in the circuit. So it is the first is called voltage controlled current source. The second is called current controlled current source. Okay. And we talk about, okay, so we can finish this section.